Okay, Unit 3, video number 6, linear versus exponential. Exponential growth occurs when a quantity grows by the same relative amount by the same percentage in each unit of time. Linear growth occurs when a quantity grows by the same absolute amount in each unit of time, constant scale factor. Example of linear, if the population of ants increased by 1,000 every month, that would be a linear progression. An example of exponential, if the population of ants increased by 20% every month, that would be an example of exponential. Linear functions take the form y equals mx plus b, and there is a little typo there, so this shouldn't have been, take the form y equals mx plus b. And then an exponential function is in the form y equals a to the x power. And I put down here at the bottom, easy to see the differences on graphs, so when in doubt, graph the equations on your graphing calculator to see a visual. All right, linear functions change at a constant rate per unit interval. As you can see in this table, so my x columns on these two are going to be the same, but you can see what's going on with the y, okay? Every single time, the y is just increasing by 2 every single time. That is an example of linear. Over here it says exponential functions change by a common ratio over equal intervals. So again, my 1 through 10 in my x column remains the same, but notice what's happening in my y. It's being multiplied by 2 every single time. So it's getting exponentially larger each time by a factor of 2. All right, example 1. Sebastian deposits $100,000 in a local bank that will pay out 5% interest every year. Is this linear or is this exponential? Well, our key is right there, the 5%. When you see a percentage, it's exponential because it's not going to be the same each year. It's going to change as the money continues to grow. All right, example 2. A certain type of corn grows at the rate of 3 inches per week. Linear or exponential? So we see here 3 inches per week. That means every week it's going to increase by 3, not by a percentage. So it is linear because it is the same numeric amount that is increasing every week. Example 3, the Munn sugar processing plant is able to process 10 tons of sugar per month. Linear or exponential? So again, here's my kicker, 10 tons per month. So each month it's going to go up 10 tons, or they're processing 10 tons. So that is the same amount each month, so it is linear. All right, example 4, this one was tricky. Exercise biologist Samantha discovered that to reduce soreness, people should start bicep curls at 10 pounds, then progress weekly to 11 pounds, 14 pounds, 20 pounds, 32 pounds, 56 pounds, and so on. Is it linear or exponential? Well, partly right away I want to go, is it the same that is increasing each week? Well, here, let's do a quick little chart. So this is the week, and this is the pounds, okay? And I'm going to say this is the difference in pounds, just so we can see the visual, okay? So here, week 1, she's starting with 10 pounds. There is no difference because that's week 1. Week 2, she's progressing to 11. That's 1 pound difference. Week 3, she's progressing to 14, which from 11 to 14 is a 3 pound increase. Week 4, she's increasing to 20. From 14 to 20, that's a 6 pound increase. Week 5 is 32. That would be a 12 pound difference. Week 6 would be 56, which is a 24 pound difference. So as we can see, this is the column that I want to look at here. Just like before we looked in the Y column, I want to look at what's different, and notice it's not the same each time. These are not the same increases. So that is why it is exponential. And we could figure out the math to what the actual exponential equation is, but right now I just need you to know, is it exponential or is it linear? All right, example 5, linear or exponential, and now I just gave you pure numbers, not a situation, just numbers. So again, you're looking at that Y column. You're focusing on that Y column. What's happening on the Y column? Well, in this problem, we're increasing by 1 each time. So because we are increasing by 1 each time, it is linear. If you put it in your graphing calculator, you would see it forms a line. Example 6, linear or exponential. So again, I need to focus on this y row here, this y row. And I'm looking and I'm going, okay, so I went from 3 to 9, and then I went from 9 to 27, and then I went from 27 to 81. I could ask, what is happening each time? Well, 3 to 9 is multiplying by 3. 9 to 27 is multiplying by 3. 27 to 81 is multiplying by 3. So this is exponential, because I am growing by a factor of multiplying by 3 each time.